Multiplying decimals by whole numbers. First, let's model what happens when you multiply a whole number by a decimal. This example reads 3, being our whole number, times 4/10. This means that we have 3 groups of 4/10. Here you will notice that I have gone ahead and taken one whole and I have divided it into tenths, and I'm going to shade in 4 of those tenths. The shaded in region here represents 4/10. So here is one grouping of 4/10. Now I'm going to duplicate that for a second time and then a third so that I have 3 groups of 4/10. Now you can see I have 4/10, a second group of 4/10, and a third group of 4/10. So I have 3 groupings of 4/10. If I were to count these out, you would see that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 groups of tenths. What I have now done here is I have taken this 4/10 and I've put it into this first block. So now I have 1, 2, 3, 4, 5, 6, 7, 8 tenths together within the same whole. And then I took 2 of these green tenths and I filled them in here as well. So that gives me one whole. There are just 2 tenths that are unable to fit into this one whole, then into the divisions of tenths. So now I find that I have one whole and 2 tenths shaded in. My answer to this problem is 1 and 2 tenths. It would take us a very long time if every time we wanted to multiply a decimal by a whole number, we drew out models and shaded in regions of the models to find the solution. So rather than doing that, we're going to talk about the rules of multiplying numbers, decimals, and whole numbers so that we don't have to do the model every time. Here we have the same problem that we modeled before, 3 times 4/10. I'm going to write it in the notation that we use to multiply, where you stack the two numbers. 4/10 times 3. Now, unlike adding and subtracting decimals, you do not need to line up the decimal point for this process. You're going to multiply the two numbers like normal. So you have 3 times 4, which is 12. Carry your 1. 3 times 0 plus 1 is 1. And this is the part where it's a little different. If you look at your original numbers, between the two, we only have 1 digit to the right of the decimal point. So here's our decimal point. We have 1 digit to the right. Because we have 1 digit to the right of the decimal point in our two numbers, our two factors, we're going to place the decimal point right here so that in our solution we also have 1 digit to the right of the decimal point. And you'll notice we now have the same solution as when we shaded in the regions using the modeling method. To write these out in steps, step 1, you're going to multiply like normal. So you're going to treat these two numbers like they're normal whole numbers. So basically 3 times 4. Then step 2, you're going to count the digits to the right of the decimals and the factors. So here we have 4/10 and 3. 4/10 has 1 digit to the right of the decimal. There are none here. So you have 1 total. And you're going to place that decimal in the product so that you have 1 digit to the right of the decimal, just like what we did from our problem originally. Example 2. 7 times 5 and 6/10. Before multiplying, let's go ahead and make an estimate. 7 times approximately 6, 5 and 6/10 is close to 6, will give us a solution around 42. So that's what we can expect when we multiply this out. When you set up your problem, you can either choose to put the 7 on top and the 5 and 6/10 on the bottom, or you can choose to flip it because of that commutative property of multiplication, so that 5 and 6/10 is in the top times 7. Either way is fine. This we may be a little more comfortable with, this right here. I'm going to multiply that way, but you would get the same solution as if you did this way right here. So I'm gonna put a big X on that and multiply this way. Okay, 7 times 6 gives me 42, carry your 4. 7 times 5 is 35, plus 4 is 39. And step 2 tells us to count how many digits are to the right of the decimal and our factors. We have 5 and 6 tenths, we have 7. 7 is a whole number, so we have no digits to the right of the decimal here. Here we find that our decimal point is here and we have exactly 1 digit. So we're going to put our decimal in our product so that we will have exactly 1 digit to the right of the decimal. So this is our 1 digit that's going to be in the decimals. So our answer is 39 and 2 tenths. This is reasonably close to 42. So I would say that this is an appropriate answer. 39 and 2 tenths. Example 3, 8 times 1 and 52 hundredths. Again, you can stack these numbers either way you want to. I'm going to put the number with more digits on the top. So I have 1 and 52 hundredths times 8. 8 times 2 is 16, carrier 1. 8 times 5 is 40, plus 1 is 41. And 1 times 8 is 8, plus 4 is 12. Look at your original numbers that we multiplied. We have the decimal point with 1, 2 numbers to the right, and then we have the whole number 8, which has no digits to the right of the decimal, so we're just going to use the 1, 2. And so when we place our decimal, we're going to 1, 2, place it right here between 12 and 16, so our answer is 12 and 16 hundredths. If we were to have estimated here, this is 8 times about 2, so our answer should be around 16, and I would say that is reasonably close. Example 4, 23 thousandths times 17. Multiply like normal. 7 times 3 is 21, carrier 2. 2 times 7 is 14, plus 2 is 16, carrier 1. 7 times 0 plus 1 is 1. 7 times 0 is 0. You can choose to put that or not. Placeholder 0. 1 times 3 is 3, 1 times 2 is 2, 1 times 0 is 0, 1 times 0 is 0. Add the two together, 1, 9, 3, 0, 0. Step 2 tells us to look at our original numbers that we are multiplying. We have a decimal point and 1, 2, 3 digits to the right, no digits in the second number, so 1, 2, 3 need to be in our solution. So I'm going to move that decimal 1, 2, 3 digits to the right. So our answer is 391 thousandths. Example 5, 11 times 75 and 9 hundredths. Okay, multiply like normal. 1 times 9, 1 times 0, 1 times 5, 1 times 7. Placeholder, don't forget that. 1 times 9, 1 times 0, 1 times 5, 1 times 7. Add together. 9, 9, 5. 7 plus 5 is 12. Carrier 1, 8. When placing your decimal, go back to the original problem. We have the decimal point with 1, 2 digits to the right, nothing over here, so we need to have 2 digits to the right in our solution. So 1, 2, both 9s are going to fall behind the decimal point. My final answer is 825 and 99 hundredths. Pause the video and try these 2 problems on your own. When you are finished, hit play and watch to check to see if your solution is correct. 2 and 5 tenths times 9. 9 times 5 is 45, carrier 4. 2 times 9 is 18, plus 4 is 22. Count the digits to the right of the decimal. Here's our decimal. We have exactly 1 here, nothing here, so we're going to have 1 in our solution. Our answer is 22 and 5 tenths. Example 2, 44 times 3 and 84 hundredths. 4 times 4 is 16, carrier 1. 4 times 8 is 32, plus 1 is 33, carrier 3. 3 times 4 is 12, plus 3 is 15. Placeholder 0. Go through the same line. 4 times 4, 16. 4 times 8, 32, plus 1, 33. And 4 times 3 plus 3 will give me 15. Add 6, 9, 8, 6, 1. Count your digits to the right of the decimal in your original problem. We have our decimal point with 2 digits, nothing behind this decimal point here. So 1, 2, our decimal will fall right there. Our final answer is 168 and 96 hundredths. And we are all done.